In many videos, we have already talked about electron configuration. And now in this video, we're going to extend that understanding by thinking about the electron configuration of ions. So these are going to be charged atoms. So let's just start looking at some examples. Let's say we are dealing with fluorine. Now, we know what a neutral fluorine atom's electron configuration would be. In fact, if you want a little bit of practice, try to pause this video and think about what is the electron configuration of a neutral fluorine atom. All right, now let's work through this together. A neutral fluorine atom has 9 electrons, and we could just use our periodic table of elements. So first, we're going to have 2 electrons in 1s, so we'll have 1s2. And then we're going to go to the second shell. So then we go to 2s2. So far we have filled in 4 electrons. And next we go to the 2p subshell. And we are going to have, if we're talking about a neutral fluorine, we are going to have 1, 2, 3, 4, 5 electrons in that 2p subshell. So it's 2p5. So if that's the electron configuration for fluorine, what do you think the electron configuration for fluoride would be? So this is just the anion that has 1 extra electron. It is a negatively charged ion. Pause this video and try to figure it out. Well, here you're now going to have 1 extra electron. The fluorine has nabbed an electron from someplace. And so where will that extra electron go? Well, our 2p subshell has space for 1 more electron. So that's where it will go. So the fluoride anion is going to have an electron configuration of 1s2, 2s2, 2p. Now it's going to have an extra electron here, 2p6, 2p6. Now let's do another example. Let's say we wanted to figure out the electron configuration of a positively charged calcium ion. So calcium, let's make it 2+. So it has a positive charge of 2. So this is, you could view this as a neutral calcium that has lost 2 electrons. What would be its electron configuration? Pause this video and try to figure that out. All right, well, one way to figure this out is first we could figure out the electron configuration of a neutral calcium atom. And then from that, we can take 2 of the highest energy electrons away. And so neutral calcium, you could view it, actually let's do it in noble gas configuration. Neutral calcium, the noble gas that comes right before calcium is argon. So it's going to have the electron configuration of argon. And then we are going to have 2 electrons for that 4th shell. It's going to fill in the 4s subshell. And so we're going to have argon, and then we're going to have, let me do this in a new color. Let's call this 4s2. Now, what do you think is going to happen if we were to lose 2 electrons? Well, those 2 electrons in that 4s subshell, in that 4th shell, are going to go away. And so the electron configuration here for calcium with a positive 2 charge, this calcium cation, is going to be the electron configuration of argon and no 4s2. So it's actually going to have the exact same electron configuration as argon. So I will leave you there, just a couple of examples, and I encourage you, if you're in the mood, just pick any of these atoms, any of these elements, and think about what would happen if they gained or lost an electron and what their electron configurations might be.